Okay, Algebra 1, we are starting our new semester and study of exponents, okay? So remember exponents, they represent repeated multiplication. So if I look at what does it mean to have a squared times a cubed? That's a times a times a times a times a, and you can see why we like exponents. Nobody wants to write all that down. This is a to the fifth. So 5a's have been multiplied. If I look at the next one, the literal meaning of this is a b squared times a b squared. So if I gather up, a multiplies by a, b squared multiplies by b squared. So this is going to be a squared b to the fourth. Now if I look at quotients, we've done this before, you've got 5a's in the top of this fraction and 7a's in the bottom of this fraction. So a over a is 1. Your final answer here is 1 over a squared. Easiest way to do this is just look at this. There are more a's in the bottom of the fraction. How many more? 2. Your answer is a squared with the a squared in the bottom of the fraction. Looking at this one, this is a over b times a over b times a over b, which is just a cubed over b cubed. So what I'm seeing here, when I have a quotient that's raised to a power, I can just raise the numerator to that power and the denominator. Now this might be the first time you're seeing negative exponents. It has nothing to do with the positive or negative sign of the number. This is just our notation for repeated division. Okay, so what this means is you're dividing by a one time. So the literal meaning of this is 1 over a to the 1. So it's division by a. The next one, you're dividing by a 2 times. This is 1 over a times a, or 1 over a squared. What you should sort of get used to is that when I see a negative exponent, so in this problem, a to the negative 1, there's a negative exponent in the top of that fraction. It becomes positive when it moves to the bottom of the fraction. Same thing here. There's a negative exponent in the numerator. It becomes positive in the denominator. This one, so it's going to be what? Dividing by a squared plus b twice. So a squared plus b, a squared b. And so this is just 1 over a to the fourth and b squared. Another way of thinking about this, this is just 1 over a squared b squared. Okay. Here I'm seeing a negative exponent in the bottom of the fraction, but a to the negative 1, this is 1 over a to the 1, which is 1 times a to the 1 over 1, which is just a to the 1. The way to think about this problem is a negative exponent in the bottom of the fraction, it becomes positive when it moves to the top of the fraction. So we have examples here. These are the rules of exponents. So anytime I have the same number raised to different powers, I add those exponents. Okay. So the example here, this is going to be 5 to the 3 plus negative 1. This is 5 squared, or 25. The power of a power. Anytime you raise a number to a power and then raise it again to another power, you multiply those exponents. So this answer is 3 to the 6th power. Anytime you have a product, you're raising it to a power, you can raise each individual factor to that power. So this can be written, this obviously I could do it 2 ways. This is 6 to the 4th, or I could do 2 to the 4th times 3 to the 4th. I just get smaller numbers to work with. This is 16 times 81, which is what? Let me get my calculator. 16 times 81 is 1296. Anytime I have a quotient, I subtract those exponents. So this is a to the m minus n, so this is going to be 6 to the negative 3 minus negative 6, which is going to be 6 cubed. And 6 cubed is 216. Power of a quotient, so you just raise both of the top and the bottom to that power. So this is 4 squared over 7 squared, which is 16 over 49. And again, negative exponents, easiest thing is this is a negative exponent in the top of a fraction. It becomes positive when it moves to the bottom of the fraction. So this is 1 over 49. Any number other than 0 raised to the 0 power is 1. Okay? So let's look at a few examples here with some radicals or square roots. The square root of 25. What number can be squared to obtain 25? So what number can I square to get 25? The answer is 5. So the square root of 25 is 5 because 5 squared equals 25. Now, there's no index right here that tells me square root. So when there's nothing there, it's assumed to be a square root. Now, when you see the little 3 there, this is called a cube root. And the question becomes, what number can you cube to obtain minus 27? What number can you multiply 3 times and get negative 27? That number is negative 3. So the cube root of negative 27 is negative 3 because negative 3 cubed is 27. Now, we can generalize this, the nth root of a. So what this means is there is a number, if I'm talking about the nth root, I can multiply b n times to get a. So if the nth root of a is equal to b, then you know that b to the n is equal to a. Now this term is just read the nth root of a. Okay. For n, an integer greater than 1, the nth root of a is a to the 1 over n power. So this is the first time you're probably seeing fractional exponents. Okay. So when I see a fractional exponent, when I raise something to the 1 over n power, that's the same as the nth root of that. And if I look, a to the m over n, a to the m over n, that's the same as a to the 1 over n times m. Okay. This term right here, this is the nth root of a to the 1 over n. So it's the nth root of a raised to the m power. You can write it this way, or you can write it with the a to the m under the root, either way. A to the negative m over m, that's just 1 over a to the m over n, which is 1 over the nth root of a to the m. So what you want to keep in mind, anytime you see something like x to the 2/3, the number on the bottom represents the root. So this means the cube root of x squared. The numerator is the exponent, the denominator is the root. Okay. Let's simplify some expressions. X squared times x cubed. This is just x to the 5th. This one you multiply the exponent, so this is x to the 6th. And this one, this is a product. If I'm cubing it, everything gets cubed. This is just x cubed, y cubed. If I look at this one, this is just x to the 5 minus 3, which is x squared. I got a couple ways of doing this next one. This is, by rules, this is x to the 3 minus 5, which is x to the negative 2. We really don't like to leave negative exponents, so this is 1 over x squared. Another way of thinking about this problem is I can do this. There are more x's in the bottom of the fraction, so I can just say this is 1 over x to the 5 minus 3 equals 1 over x squared. So what you can do is wherever you have the bigger number, do the subtraction from there. So 5 minus 3 gives me 2, but the answer is going to be in the bottom of the fraction. Or just think of it in that expression, where are there more x's? They're in the bottom of the fraction. How many more? 2 more. This one is just simply x to the 4th over y to the 4th. If I look at the next one, I've got several things going on. Let's just see, okay, I've got all of this in the numerator in that fraction that gets raised to the second power. So this is going to be 2x. When you multiply the negative 1 and 2, you get negative 2, and you get y squared. On the bottom, you've got x squared, y to the negative 3. Now, why don't we just move everything that's a negative exponent? So the 2 stays where it is. That x to the negative 2 can go to the bottom of the fraction. The y squared stays where it is. And then on the bottom, the x squared stays where it is. And then that y goes to the top. So this gives me 2 y to the 5th over x to the 4th. Now the next one, it looks quite complicated, but just keep in mind, this is the ugliest part, but this is 1. When you raise this to the 0 power, that's 1. So this is 2x to the negative 2 over x. So let's take care of the negative exponent. So 2x squared times x. So this is 1 over 4x squared times x. 1 over 4x cubed. So again, I'm just following rules of exponents, not making up my own as I go in order to get this. Now let's pay close attention to the positive and negative signs. 2 squared, this is 4. Negative 2 squared, so it's negative 2 times negative 2, that is also 4. But the next one, negative 2 squared, only the 2 is being squared. So this is the negative of 2 times 2. This is negative 4. 2 to the negative 2, this is 1 over 2 squared. This answer is 1/4. Negative 2 to the negative 2, this is 1 over negative 2 squared. That's 1/4. Okay. Negative 2 to the negative 2, only the 2 is being raised to the negative 2, so this is the negative of 1 over 2 squared. So this one is negative 1/4. When I see a fraction with a negative exponent, so it's going to be 1 over 1/2 squared. The easiest way to do it is just to flip this fraction. This is 2 over 1 to the second power. Because if you distributed this, you would have 1 to the negative 2 over 2 to the negative 2. And that's just going to be 2 squared over 1 squared. So this is just going to give you 4. The negative of 1/2 to the negative 2, this is the negative of 2 over 1 squared. So that's negative 4. Now let's evaluate some of these. The cube root of negative 64, a number that gets multiplied 3 times to give me negative 64. So that's going to be negative 4 times negative 4 times negative 4. So the cube root of this is negative 4. The square root of negative 64, is there a number that you can square? So is there a number that you can square and get negative 64? Well, if you multiply a number by itself, if it's positive, you get positive. If it's negative, you get positive. So this is not real. In later math classes, you'll learn that this is a complex number that's sort of beyond the scope of what we're doing. So this is not a real number. The square root of 1 over 64, this is just the square root of 1 over the square root of 64, which is 1/8. Negative of the cube root of 64, the number you multiply 3 times and get 64 is 4. This is just negative 4. This one, the square root of negative 64, we've determined that is not real. So I cannot take the square root of a negative number. Cube root, negative cube root of negative 1/64. Okay, so this is, I can rewrite this as negative cube root negative 1 over cube root 64. What number do you multiply 3 times and get negative 1? That's negative 1. What number do you multiply 3 times and get 64? That's a 4. This answer is 1/4. Convert the following to radical form and then evaluate. So when I see a fractional exponent, the bottom part is the root. So this means the fourth root of 81 cubed. The fourth root, what number can you multiply 4 times and get 81? That's 3, because 3 times 3 times 3 times 3 is 81. So this is just 3 cubed, which is 27. Negative 27 to the negative 4/3. So this is negative 1 over 27 to the 4/3. Now take care of this fractional exponent. The 3 is the root, so this means cube root of 27 to the 4th power. What number do you multiply 3 times and get 27? That's a 3. So this is negative 1 over 3 to the 4th, which is negative 1 over 81. Negative 32 to the negative 2/5. The exponent only works on the 32, so move this 32 to where it gets a positive exponent. So this is negative 1 over, and that means the 5th root of 32 to the 1st power. What number can I multiply 5 times and get a 32? That's a 2. So this is negative 1 over 2. Negative 64 to the negative 3/2 power. So this is 1 over negative 64 to the 3/2. So that bottom is the root, so it's 1 over the square root of negative 64 cubed, and this is not real because we cannot take the square root of a negative number. Write this in radical form, okay? So this is 2, and then it's the cube root of x squared. Or you could write it 2 cube root of x squared. That exponent can be either inside or outside the radical sign. The next one, this is just 4 over xy to the 3/5. So this is 4 over the 5th root of xy cubed. The next one, okay, I got a little bit of work to do here. Let's do the one on top. Write this in exponential form with positive exponents. So this is 2, and it's 3x squared. The 4th root is the same as raising it to the 1/4 power, okay? So I could leave my answer like that, or it's 2 times 3 to the 1/4 times x to the 1/2. Either way. Look at the next one. I want to write everything with exponents. So this is 2 y to the 6/7 over. Now the 7th root of 128, let's just write it. 128 x to the 7th, y to the negative 1 to the 1/7 power. Okay, so I get 2y to the 6/7. 128 to the 1/7. That means the 7th root of 128. What number can I multiply 7 times and get 128? That's a 2. So 2. Then I'm going to need to multiply this exponent and this exponent. So that's going to give me x to the 7 over 7 power. And then you're going to get y to the negative 1/7. So the 2's cancel. You've got y to the 6/7. Move this y to the negative 1/7 up top over x. Add those exponents. 6/7 plus 1/7 is 7/7 are 1. This answer is just y over x. Simplify this fraction. So I've got something raised to a power raised to another power. I multiply exponents. So this is 27 and then 2/3 times 1/2. This is 27 to the 1/3. That just means the cube root of 27. That is the number 3. Simplify completely. This one's a little bit more involved. In order to get this thing simplified, I need to write everything as powers of the same number. So I'm going to use the fact that 64 is 4 cubed. So I'm going to rewrite this. This is 4 cubed to the 5/9 times 4 cubed to the 2/9 over 4 to the 3/4. Okay. I can add these exponents. This is 4 cubed to the 7/9 over 4 to the 3/4. Now multiply exponents. 4 to the 21 over 9 over 4 to the 3/4. So this is going to be 4 to the 21 over 9 minus 3/4. Common denominator is 36. So I'm going to have 84 over 36 minus 27 over 36. Is that right? And so this gives me 4 to the 7. Did I do that right? Let's see. 21/9, so multiply by 4, 84, 4 gets multiplied by 9, 27, oh, it's 57, sorry. $57 over 36, those are both divisible by 3, so 4 goes into there, 19 over 12. Okay. Looking at the next one, I can just flip this guy around. This is 4 cubed over 7 cubed to the 1/3. So this is 4 to the, when you multiply exponents, 3 times 1/3 is just 1. 3 times 1/3, this answer is just 4/7. Okay? And that should take us up into the homework for this section.